Hi there, in this screencast I'm going to solve some of the problems you might see on tomorrow's quiz on higher order radicals. So in the first four problems I'm asked to rewrite a radical expression in exponential form. So when I do that, whatever the exponent is becomes the numerator of my exponent, and whatever the index is, and if there's no index written there it means it's 2, becomes the denominator. So that means this first one is really x to the 3 halves. The second one would be 5x to the 5 halves. The third one is going to be v to the 5 halves. And the fourth one is going to be 5b to the 1/4. Because if there's no exponent, it really means it's a 1. Okay, now I have some equations to solve involving higher order radicals. So the method for solving these is always to get the radical isolated on one side of the equation all by itself. So to do this for the first one, I'm going to subtract 2 from both sides. That's going to give me the 4th root of n plus 8 is equal to 3. And now the key step is to raise both sides of the equation to a power that's the same as the index of the radical. So that causes the radical to disappear on the left, and I would just be left with n plus 8 equals 81. Then I'm going to subtract 8, and I get n equals 73. Alright, so in the next one, I have the third root, and I'm going to still do the same thing. I'm going to isolate the radical all by itself on one side of the equation, and then I'm going to raise both sides to a power equal to the index of the radical. That's going to cause the radical to disappear, and I'll be left with p equals 27. That's what 3 cubed is. Alright, now in the final few problems I have square roots that I'm working with. So let's see. There we go, that's one of them. Okay, so I have the square root of 2r minus 2. Well, the radical's already isolated on the left side of the equation. So I'm going to raise both sides of the equation to a power equal to the index of the radical. That gives me 2r minus 2 equals 4. Then I'm just going to add 2 to both sides, giving me 2r equals 6. Now I divide by 2, and I get r equals 3 as my solution. Okay, same goes for this one, except I need to subtract 7 to move it to the right side, and I get square root x minus 8 equals 10. Then I'm going to square both sides of the equation, and that's going to give me x minus 8 equals 100. Then I'm going to add 8 to both sides and get x equals 108. Okay, and these last two I'm going to end up with quadratic equations that I'm going to solve by factoring, and these are also going to involve a little bit of foiling as well. So just like before, I want to get the radical all by itself on one side of the equation. So I add m to both sides, and now I'm ready to square both sides of the equation, so I get m minus 1 equals. So m minus 1 squared is really that. So I have to FOIL it, and I get m squared minus 2m plus 1. Then I want to get a 0 on the left side of the equation, so I'm going to subtract m and add 1. That gives me something that I can solve by factoring. So that would be m minus 2 times m minus 1 equals 0, and that means m equals 2 or m equals 1. Alrighty. And the last problem here, number 10, I'm going to add a, because remember I always want to get the radical all by itself on one side of the equation. And now I'm going to square both sides. So that gets rid of the radical on the left. And if I FOIL that, I get a squared minus 4a plus 4. And now I need to subtract 3a and add 8. And let's see, that gives me a squared minus 7a plus 12. So I factor that, a minus 4 and a minus 3. And that means my solutions are going to be a equals 4 or a equals 3. And that would be it. Alright, secret sentence for tonight's screencast is the following. The life you save may be your own. Alright, hope this was helpful, and we will see you tomorrow. Cheers.